are you going to do today? Any ideas?
I think we should do something related with Malaysian current problems. What are problems are Malaysian facing right now? I think we can do about flood. We can also do about noise.
I think we can do about air pollution.
What about we do about water pollution?
Water. Why water?
Because access to clean water nowadays is very difficult. And then the safety and purity has also emerged as one of our top priorities in Malaysia. What do you think are the necessity and what are the problems that Malaysians are facing right now for the water quality?
Nowadays, Malaysia is lack of real-time attention and response.
Maybe Malaysia also is sufficient in terms of sensor technologies.
I think Malaysia very lack of coverage about water cleanliness.
Okay, I agree with all of those. But also, Malaysians' water quality drinking has also given us a lot of health disease, which is also causing us diarrhea, hepatitis A with thyroid.
Okay, so now what are the solutions that we can do to solve these problems?
We can create a system that we can monitor the water source.
Or maybe we can use some reliable sensor technologies items to monitor our water quality better.
We can also add a real-time monitoring system so that we can check in all the cleanliness of water in real time.
So doing all this will also help us with improving the water quality and also stop the waterborne disease.
Oh yeah. So now I think we can all start to find all the components needed for our water quality monitoring system. Thank you.
I agree.
So guys, now we are going to introduce all the items, all the hardware devices that you bought from the store. So first, we have a device named Arduino Uno. So this device is to communicate with other devices such as sensors, okay, and LCD or analog input/output. So with this Arduino Uno, it can read signals from the sensor to generate voltage fluctuations. So next, we have ESP32. This one, okay. So this one is to connect with TeamSpeak because it has a built-in Wi-Fi chip. So with this ESP32, we can connect to TeamSpeak and send our data to TeamSpeak, which is a cloud server. And last one, we have one of the most important thing which is breadboard. So breadboard is used to connect all the wire jumpers that connect with the sensors, LCD, and all the device with such as Arduino Uno. So that is the use of breadboard.
Okay, so this is the temperature sensor, which is DS18B20. It is a waterproof temperature sensor. The temperature sensor is a device used to measure the heat of the water, or whether the water is cold or whether the water is normal. So we are going to use this for our project. And then this is LCD. LCD screen is of course to display the characters. So this one will display our turbidity sensor, whether the water is clean, normal or dirty. Okay.
So this is jumper wire. Jumper wire used to connect two places on a breadboard or any electrical circuit board. It has three different categories, which is male to male, female to female, and male to female. And then this is our turbidity sensor. It used to sense any particle inside a solution, for example, water, which is suitable for our project.
So software that we use is Arduino IDE, which is the software is a platform that we use to create our programs for the Arduino boards. And ThinkSpeak. ThinkSpeak is our platform that we use to gather data from the connected device, such as temperature sensor. So we already chose our hardware and software. So now we're gonna continue on assemble the hardware that we buy.
this is our complete system. We have assembled all the sensors, which is this is a turbidity sensor. We connect with Arduino Uno, and the readings here will go to here. Will display at the LCD. Okay, and then we also connect the temperature sensor with ESP32. So now we move on to the next video where we will attach four of us assemble and connecting all the components together. So let's go.
So Iman already showed you how about the connection. Now we are going to move forward to the next vlog where we connect the ESP to ThinkSpeak. So this is our temperature sensor. The temperature sensor will be connected to our ESP32. So the ESP32 will send the data to ThinkSpeak, where our ThinkSpeak will be connected to our personal Wi-Fi.
So this one is the ESP, it's connected to the phone here. Then this is the ThinkSpeak. Okay. So now Iman will explain the codes.
So now here's the code. Okay. So we include all the important libraries that we need for our temperature sensor. So these are the libraries, and then we define the pin that we use to connect temperature sensor with ESP32. This is SSID, Wi-Fi name and password, and API key for ThinkSpeak. So this is the code. Okay, so void setup. So here we will start the ESP to connect with Wi-Fi, which is we already defined lah in this part. Okay, and then in the void loop, okay, this is where the sending the data to ThinkSpeak code lah. We put it here. As you can see, the code here HTTP to string server field 1. So field 1 here is refer to this one, field 1 chat. Okay, so that's all lah.
Okay.
So finally we are reaching our final log. Now we will working on the prototype on stability and temperature sensor. Although we face many challenges, we managed to overcome it. So my group member will continue on the working prototype.
Alright, so welcome back guys to our final vlog 5. So as you can see here, we explained already in the vlog 4. This is the code for temperature sensor. So now we test lah our code working or not. So this is the previous test lah. So now the latest one, okay. So now we put it in the cold water. Okay, just put, okay, and then we observe lah our ThinkSpeak, our field chart It takes about 15 seconds lah based on our code. So just need to wait 15 seconds. If it's supposed to drop.
Okay, hi. So now I'm going to show you on the turbidity sensor. So as you can see here, these are the codes for the turbidity sensor. We've also used the LCD to print out welcome to turbidity sensor. And then here is going to show us the LCD will print if the NTU of the water is less than 5, we will get water clean. If it's more than 5 and less than 10, we will get water normal. And if it's more than 10, we will get water dirty. Okay, so now I'm going to verify the codes. And then running. So now the word code is verifying, is compiling the sketch. So this shows that there's no error in the code. And then here it's compiling the sketch. And it's done compiling. So now you can see that the screen of the LCD is going to show you welcome to turbidity sensor. Okay, now we're going to demonstrate the clean water. So as you can see, there is no changes because this is purified clean water, purified water from Kowe machine, so it's clean. Okay, so now we're going to show you the dirty water. This is lemon juice, lemon water. So this is supposedly show us normal water, normal, because it's not too dirty and it's not too clean. So as you can see, okay, since the water is a bit dirty, it's on the dirty part, it's showing us water dirty. But if you can see closely, it will change to water normal. This is watercolored water, so the water is a bit thick and there is no light gray inside, so it should be showing us water dirty. Okay, if you can see, it's going to water dirty. Okay, so this is the end of our vlog. Hope you all enjoyed.
Bye.
Bye. Hi.
Okay.
Okay, so for the reflection part of the video, we're going to reflect on our journey from the beginning until the end. So,
Yeah.
Iman, let's go.
Okay, so what I experienced during our project is we managed to complete lah this task because we have so many problems that we face, such as most of us not have an actual time to meet, so to do this task together lah. So we have to endure the difficulties lah, and then from that we learn to how to work together as a team. And then how about you? What do you think?
Yeah, I agree. The teamwork was excellent.
Yeah.
Everybody helped each other, and no one didn't do anything. So that's good. And then components and also the hardware, it was a bit difficult to find, but we managed to find everything.
Yeah.
And then what else?
Then we learn something new lah. Macam we learn about Arduino, blah blah blah, and Arduino and ESP32, and we learn lah how to coding that one, even though we haven't done it before. So that's what good lah for us. New input
How
lah.
about you? I think the challenge is how to maintain the result in terms of flexibility, and then doing a research in terms of the coding, because there are a lot of resources, and to find the right one that match our hardware and software. What about you, Naima?
I think I agree with all of you because that we are facing, and I also